Hello everyone, our topic today is all about set score problems. Standard normal distribution. It is also called set distribution, and mean or mu is equal to 0 and standard deviation sigma is equal to 1. So under normal distribution x, we are going to convert it to a standard normal score, which is the set score. To do this, we are going to use the formula set is equal to x minus mu over sigma, where x is the observed value and mu is the mean and sigma is the standard deviation. Always remember that set score is the number of standard deviations from the mean. We are going to use this table, this set table, which is the less than cumulative frequency, because we have the negative set and the positive set. So in the summary, if we are looking for the less than area, whatever the area in the table, it is the answer. So the answer for this one is 0.9525. But if ever that it is greater than area, we are going to subtract it from 1. And then determining in between, we are going to subtract the area of the larger set value minus the area of the lesser set value. Remember that we only subtract the areas, but not the set values. So let us have problem number 1. Deviation IQ scores, sometimes called Wechsler IQ scores, are scores with a mean of 100 and a standard deviation of 15. What percentage of the general population have IQs lower than 92? So in here, we are going to use the formula set is equal to x minus mu over sigma. So substituting all the values, we get x is equal to 92 minus 100 over 15. So in here, using the calculator, we get negative 0.53. To understand how to find the percentage of the general population have IQs lower than 92, we use the normal curve. So set is equal to negative 0.53 is located here, and we are going to determine this area. So we are going to get the value in the set table. So it is equal to 0.2981. So P, the probability of x greater than 92 is equal to 0.2981 when we are talking of lower than or less than, okay? So since the problem is asking about percentage, we are going to multiply it by 100%. So the answer is the percentage of the population with IQs lower than 92 is 29.81%. So in getting for the probability of the set value, so in the first column, take a look at negative 0.5. And in the top row, take a look at 0.03. So it intersects at 0.2981. So meaning set which is equal to negative 0.53 is equal to 0.2981. So let us have problem number 2. In recent year, the ACT scores for high school students with a 3.50 to 4 GPA were normally distributed with a mean of 24.2 and a standard deviation of 4.2. A student who took the ACT during this time is selected. Find the probability that the student's ACT score is less than 20. So using the formula set is equal to x minus mu over sigma, we are going to have 20 minus 24.2 over 4.2, having set is equal to negative 1. From the set table, set which is equal to -1 is equal to 1.587. Since we are looking for less than, whatever the value in the table will be the final answer. And the probability, so no need to multiply by 100%. So the probability that the student's ACT score less than 20 is 1.587. So how did we find set is equal to -1? Looking at the negative set table, look at in the first column -1.0 and the first row which is 0.00. So the intersection is equal to 0.1587. That is how you use the set table. Now let us have problem number 3. Deviation IQ scores, sometimes called Wechsler IQ scores, are scores with a mean of 100 and a standard deviation of 15. What percentage of the general population have IQs greater than 130? Using the formula, we will be getting 130 minus 100 over 15. Using the calculator, it would be equal to 2. Then, using the normal curve, set is equal to 2. So, using the set table, it is equal to 0.9772. So, it means that this area is equal to 0.9772. The problem is asking us what percentage of the general population have IQs greater than 130. So, therefore, this is the area that we are going to solve. So from this, we all know that a normal curve composed of 1 or the total area is equal to 1. So therefore, we are going to subtract 0.9772 from 1. So the probability of x greater than 130 is equal to 1 minus 0.9772, which is equal to 0.0228. So the percentage of the population with IQs greater than 130 is 2.28%. Because we are looking for percentage, we are going to multiply it to 100%. Let us have problem number 4. In recent years, the ACT scores for high school students with a 3.5 to 4 GPA were normally distributed, with a mean of 24.2 and a standard deviation of 4.2. A student who took the ACT during this time is selected. Find the probability that the student's ACT score is greater than 31. So using the formula, we have 31 minus 24.2 over 4.2. Using the calculator, it is approximately equal to 1.62. Getting the set value of this one, it is equal to 0.9474. Since we are looking for greater than, we are going to subtract it from 1. So the probability that x is greater than 31 is equal to 1 minus 0.9474. And since we are going to solve for the probability, so no need to multiply it by 100%. So the answer is the probability that the student's ACT score is greater than 31 is 0.0526. So let us have problem number 5. In recent years, the ACT scores for high school students with a 3.5 to 4 GPA were normally distributed with a mean of 24.2 and a standard deviation of 4.2. A student who took the ACT during this time is selected. Find the probability that the student's ACT score is between 25 and 32. So in here, take note of the word between. So first, using x is equal to 25, we are going to solve for set 1. So 25 minus 24.2 over 4.2 is equal to 0.19. And then using x is equal to 32, set 2 is equal to 32 minus 24.2 over 4.2 is equal to 1.86. Using the set table, the probability of set 1 is equal to 0.5753, and the probability of set 2 is equal to 0.9686. So that we can visualize the problem, let's use the normal curve. So this one is set 1 and this one is set 2. So we are going to solve this area. To solve for this area, we are going to subtract 0.9686 minus 0.5753. So always subtract the bigger one first minus the lesser one because there is no negative area in the history of mathematics. So in doing this, we get 0.3933. Since we are looking for the probability, so our final answer would be 0.3933. Now let us have a short quiz. In United States, the average IQ is 100 with a standard deviation of 15. What percentage of the population would you expect to have an IQ lower than 85? In 10 seconds, answer the question. That's right. The answer is 15.87%. That's all for now. Thank you for watching. Please click the subscribe button. See you again next time. Bye!